Hello, dear aspirants. This is Dr. Saurabh Sir's classes. Our contact number is 9836793076. Again, I am repeating our contact number, which is 9836793076. And our email ID is saurabhsirclasses@gmail.com. So, if you have any mathematical queries or any questions or any doubts, so please feel free to contact on this number. That means you can call on this number or WhatsApp also. Rather, you can drop an email to our email ID. Then our team can arrange a doubt clearing session for you. After that, you can join our regular batches, our one-on-one sessions, and our online classes. So that will be beneficial for your preparation of upcoming examinations like Oxford AP Calculus, etc. So please feel free to contact if you need any help from us. So now we are going to solve a problem which is appeared in the Oxford AP Calculus previous year question. And the question is telling us that a particle moves along the x-axis so that its velocity at time t greater than equals to 0 is given by v of t is equals to ln of t square minus 4t plus 5 minus 0.02 t. So the question 1 is telling us that there is one time t equals to tr in the interval 0 less than equals to t when the particle is at rest not moving. For find tr for the 0 to 0 less than t less than tr is the particle moving on the right or to the left. Give a reason for your answer. So my uh, given v of t, or I would write with this, that is equals to ln of t square minus 4t plus minus 0.2. Very good. So we can also write it as, okay, so that is not, that cannot be done here. Okay, very good. So so we have to find tr. So what we will get now? So where our vtr, we can say that our item or the particle will rest. So our velocity will be then 0 because our particle is at rest. So the ln of tr square minus 4tr plus 5 minus 0.2 tr is equals to 0. Very good. So we can also write it as our ln tr square minus 4tr plus 5 minus that is equals to 0.2 t. So now exponentiate both sides. So then we will get this thing will be my tr square minus 4tr plus 5. So this thing will be e to the power 0.2 t. Very good. So now if we solve numerically or if we apply the Newton's method, then we will get the approximate answer which is this. Because I am left, so sorry, I have left the original calculation here because this is very big. If you have any doubt, so please ask in our comment section, or you can direct contact to our contact number or email id. Then we can, then the original calculation of the Newton's method will be done there. Okay, so now the question, so now what can be done here? So we are going to determine the direction of motion for 0 less than t less than tr. Very good. So evaluate v of t at t equals to 1. since our TR is equals to 1.07, or we would write approximate. Yeah. So our V of 1 is equals to ln of 1 minus 4 plus 5 minus 0.2 into 1. So that is ln 2 minus what, 0.2. That is approximated as 0.69. Okay. So because our ln 2 is 0.71 also, if we minus 0.2, so then we 0. Okay. So we can easily say that since our V of t is greater than 0 for 0 less than equals to 2 less than equals to 0, sorry, since our Vt is greater than 0 for 0 less than t less than tr, the particle is moving to the right. So the final answer will be our tr can be approximated with this 1.071, and the particle is moving to the right for 0 less than t less than tr, because our V of t is greater than 0. So let us see the second question here. So what they gave to us, find the acceleration of the particle at time t equals to 1 and a half. So the setup for your calculations is the speed of the particle increasing or decreasing at time t equals to 1.5. Explain your reason. Okay, very good. So now let me write with another color here also now. So now find the acceleration at t equals to 1 and a half and determine if speed is increasing or decreasing. Okay. So our acceleration A of t is equals to V of t my sorry V dash t is equals to 2t minus 4 by t square minus 4t plus 5 minus 0.2. Okay, very good. So this is the only derivative with respect to t. So they gave us ln of t square minus 4t plus 5. So then the derivative of ln t with respect to t is, we know that that will be 1 by t. So we got it here, and the derivative of t square minus 4t plus 5 is 2t minus 4 with respect to t. Okay. So now we are going to compute a of 1 and a half. So that is equals to 2 into 1 and a half minus 4 by 1 and a half whole square minus 4 into 1 and a half plus 5 minus 0.2. Very good. So our 2 into 1 and a half will be 3 minus 4, and this thing is 2.25 minus this thing will also be 6 plus 5, and this is our minus 2. Okay, very good. Minus 0.2. So that is minus 1 upon that will be minus 1. So that will be 1.25 minus 0.2. So that is minus 0.8 minus 0.2. So we would get minus 1 meter per second square. Okay. So now step 2 will be determine if the speed is increasing or decreasing. So speed will be what? The speed will be mod of Vt. Very good. So at t equals to 1 and a half, our V of 1 and a half is equals to ln 1.25 minus 0. So that will be approximated by 0.0223 minus 0.3, and that will be minus 0.077. So that is, we can easily see that this thing is negative. Okay. So since our v of 1.5 is less than 0 and our accel acceleration at 1.5 is also less than 0, the speed is increasing because the both velocity and acceleration are negative. That means the particle is speeding up in the negative direction. So the final answer is our a of 1.5 is equals to minus 1 meter per second square. Okay, very good. And another thing, at t equals to 1.5, because vt and at have the same sign, both negative, so speed is increasing. Okay, so now we are moving towards the part C of this question. So part C is saying us that the position of the particle at time t is x of t, and its position at time t equals to 1 is x of 1 is equals to 3. Okay, so find the position of the particle at time t equals to 4. So show the setup for your calculation. So we have to calculate the x of 4. So we got x of 0 equals to 2. Okay, so we have to find x of 4. So what can we do? We can do that our x of t is equals to x of 0 plus that would be, sorry, what is happening with my cursor? Yeah. So that will be 0 to t vs ds. Very good. So then we can write it as x of 4 is equals to x of 0 plus integral 0 to 2, that will be vs ds. So we can, oh sorry, that will be 0 to 4. Yeah. So in the next step we can write x of 4 is equals to 2 plus that will be 0 to 4, and our v is ln of t square minus 4t plus 5 minus what? Sorry, that will be now s, because the variable of this is s, and so that will be 0 0.2 s whole ds. Very good. So let us split up the integral. So then we would get, okay, very good. So let us compute now. So this integral is super easy because we that will be limits are 0 to 4. Okay, very good. So 0 0.2 into that will be what? A square upon 2, and that will be 0 to 4. And then we would get 4, so that will be 0 0.2 into 16 upon 2 minus 0. So we would get 0 0.2, that will be 0 0.1 into only 16. So the correct answer of this part will be 1.6. So now we have to evaluate the middle integral. Okay. So how can we do this? We can do another thing. So let us take the integral from 0 to 4. We get, let us make this whole thing x. No, x is a variable here. Let us make the whole thing y. So now our y, okay, if we take this thing, that means as a square minus 4s plus 5. Then the ds will be, there is ds here. If we take this thing as d of 2s minus 4 here, and if we get a half outside, then what we will get? Then that will be 0 to 4 half, or this will appear like ln y dy. Okay, so the integration of ln x is what? Do you know? So that will be, where is my cursor? Yeah, so that will be half into ln of a square minus 4s plus 5 into the whole thing, a square minus 4s plus 5 minus of a square minus 4s plus 5, and then we will get integral, the limits are 0 to 4. So we have to calculate this now. So we would get half into, that will be ln of 16 minus 16 plus 5, and 0, for the 0 part we would get minus 5. Very good. And also in this thing we would get 16 minus 16 plus 5 minus 5, and minus of 16 minus 16 plus 5 minus 5. So now they are appearing to be 0. Okay, so this thing is 0 and this thing is also 0. So this thing is need not be calculated, so we would get 0. Okay, so this middle part will be 0, so we would get 2 plus minus 1.6. So our x of 4 is equals to 2 plus 0 minus 1.6. So the answer will be 0.6. Very good. Meter. And so now the total distance traveled from t equals to 1 to t equals to 4 is the question for the part D. Let us see. So yeah, find the total distance traveled by the particle over the closed interval 1 to 4. T belongs to 1 to 4. So the setup for your calculations. So find when our v of t, let us write with another color. So v of t is equals to 0 in closed interval 1 to 4. So our v of 4 is what? That is ln of 16 minus 16 plus 5. Sorry, that will be minus 0.8. So we would get only ln 5 minus 0.8. So that can be approximated with 1.609 minus 0.8. So that will be, or that should be 0.809, which is greater than 0. Since our Vt changes sign only at Tr, the particle changes direction once. So now we are going to compute the distance. So let us see what we would get. So 1 to Tr, we would get mod of Vt plus we would get Tr to 4 mod of Vt. So, but our Vt is greater than 0 and our T is greater than Tr. So, the distance will be now what? So, that will be 1 to Tr, that is simply Vt dt, plus that will be Tr to 4, simply Vt dt, or that will be simply just integral 1 to 4 Vt. So so let us compute the easy thing. So this part is so easier now. 1 to 4 and the integral of ln t square minus 4t plus 5 dt minus 0, sorry, that is 1 to 4, 0 0.2 det. Very good. So now using this integral, this is from 0 to 4, and if we take 1 to 4, then we would get, just put this part as 1. So let us see what we get. So by using the same integral, we would get ln of half outside 16 minus 16 plus 5 minus 1, then we would get plus 4 minus 5 dt, then sorry, into that will be the same thing, 16 minus 16 plus 5 minus 1 plus 4 minus 5. Very good. And the whole thing will be minus from this. 16 minus 16 plus 5 minus 1 plus 4 minus. Okay. So, and in this part, we would easily calculate that. So, we would get 0 0.1 into, that is just only, sorry, where is the T? Yeah, that is T. There is also a T. Oh, that's a typo. Sorry, guys. So we would get T square here. So 1 to 4. Then we would get only 16 minus 1 into, we would get 0 0.1. So that will be 1 point. And so from this, we would get 16, 16 cancel, 5 and 5 cancel. 16, 16, 5, 5. 5, 5, 16, 16. So half, and there is 3 here. So 3 by 2 ln 3 minus. Okay. So let us see what is this. So this is the correct answer of this question. So guys, I think you understood this solution. So please feel free to contact if you need any help from us. So then our team can arrange it out clearing session for you. After that, you can join our regular batches, our one-on-one sessions, and our online classes. So that will be beneficial for your preparation of upcoming examinations. Okay. Hope you understood, guys. Thank you.